solve question 105, construct binary tree from preorder and inorder traversal from LeetCode. Let's jump to the question. Given that two integer arrays, preorder and inorder, where preorder is the preorder traversal of a binary tree and inorder is the inorder traversal of the same tree, construct and return binary tree. So what this question is asking us, the question is saying two arrays are given which are preorder and inorder of the binary tree, and we are supposed to return a binary tree using these two arrays. Okay, so let's see what inorder and preorder means. Inorder means we traverse the tree from left, root, right, and preorder means we traverse the tree from root, left, right. So how can we use these two inorder and preorder arrays to create this binary tree? What we know from here is the preorder starts with the root, which is going to help us to divide the array, the inorder array, to the left side and right side nodes of each node. This way we know what we have, what is the root node, and we can divide the inorder array to the nodes either left side of the root node and the nodes on the right side of the root node. So what do I mean by that? So as I said, it starts with the root node. So 50 is the root node. If I find this root node here, which is here, so we know that whatever comes before this node are going to be at the left side of this node, and whatever comes on the right side of this node are going to be at the right side of this node. And when we traverse this preorder array, the next node is going to be root node as well. So this is what happening here. So whatever comes at the left side are going at the left side of this node, and whatever comes at the right side, which is nothing comes at the right side, are going to be at the right side of this node. And we keep traversing the preorder. So now we have 20, so we know whatever comes left and whatever comes right are at the left side and right side of this node, right? And I will do just one more. So 18 is going to be the root node, whatever comes left, which is nothing, so there is no node after that, and whatever comes right, which is nothing, so it's gonna be the leaf node, right? So how can we use this to build this binary tree? For doing that, we are going to create a hash map of this inorder array to find the indexes quickly. And the reason that we are using hash map is because the lookup in the hash map is constant. So let's jump to the code and see how it works. So as I mentioned, we are going to create a hash map of the inorder array, this one, which is created here. As you see, this is 0, 1, 2, 3, 4, right? The hash map is created here, and what we are going to do, we're gonna traverse the preorder one and create our binary tree. So let's see how we can do that. This is a recursive thing that's happening based on what I explained here. So what we are going to do, we are going to use a helper function to call this action recursively. So, and we start the helper function with index 0 and index the length of the array -1, which is going to be index 4. So we start with index 0 and index 4 to build our tree. So what we are going to check here, we are going to check if the left index is not bigger than the right index, which is not 0, is not bigger than 4. And if it is not, then we are going to pop the first item at index 0 from the preorder one, which is 3. And then we are going to create a node with that, right? And then we are going to check this number 3's index in the hash map, which is index 1, as you see here, right? And then we need to make the left nodes and right nodes of this root node, right? So we for the left root node we're gonna call the helper, and this time it's going to be the left index that we had here, and the the right index is going to be index -1. So the left index comes from the left index of the previous helper, and right index comes from the index -1 here, right? And then we are going to check if 0 is not bigger than 0, and we are going to pop the next item, which is 9, and we are going to build a node here, and then we are going to check the index of 9 in the hash map, which is 0, as you see here, right? And now we are going to use this index and this index to call the helper function again. And as you see, 0 is bigger than -1, so we are going to return none, right? So it's going to be none here. And for the next one, the same thing is going to happen here. As you see, this comes from here, but for the right side one, so it's going to be index +1, and the right side it's going to be sorry, I made a mistake here, let me remove that. So this comes from here, and this comes from here, right? This comes from here, and this comes from here, the index +1 and right. And as you see, 1 is bigger than 0, so we're gonna return none here. So let's go to the right side. Now we are going to do this for 2 and 4, which 2 comes from here and 4 comes from this side. We're gonna pop the 20, and we're gonna check the index. We're gonna create a node 20 here, and we are going to check the left side and right side. 15 is going to be created here. Just quickly go through this, and 7 is going to be here and at the right side. And as you see, 2 is bigger than 1, 4 is bigger than 3, 3 is bigger than 2, 5 is bigger than 4. As you see, there is no leaf node here, and these are all null. So this is how we are going to build the tree. The time complexity for this problem is going to be linear, because we have to traverse this array once to build our hash map here, as you see, to build the hash map here. And we are going to pop here, so we are not actually traversing the tree, but we kind of do. And the space complexity is going to be on, because of the hash map that we have and the stack that we are using. Thank you.